principle we will see. In that first application will be the Venturi meter. What is the use of Venturi meter? Nothing but to measure the velocity of the fluid in a pipe. At any cross section you have to measure the velocity of the fluid, nothing but you have to use the Venturi meter. And then one more thing will be there, that is the Torricelli's theorem. What is the Torricelli's theorem? Nothing but whenever a hole is there at the bottom of the tank, otherwise at the middle of the tank, anywhere it might be, what is the velocity of the fluid coming out of that hole? That is what you have to find out, that is the velocity of efflux we call. Velocity of the efflux can be found out by using the Torricelli's theorem. And also the Venturi meter. What is the use of Venturi meter? To find out the velocity of the fluid in any pipe, any cross section of the pipe we have to find. That is about the Venturi meter. Then one more, some more applications will be there, that is dynamic lift. What the dynamic lift means? The aeroplane will be lifted up. How it is possible? Nothing but by using the Bernoulli's principle only again. By that we call as dynamic lift. And also Magnus effect will come. What is the Magnus effect? Nothing but whenever you are throwing a ball normally, at that time what happens? Nothing but it will go as a level, as it is whichever the level you have thrown. Whenever you are spinning it, at that time what happens? Nothing but it will rise to the more height. How it will rise, that and all will be based on the Bernoulli's principle only. And also sprayer, pump sprayer will be there. That will also work based on the Bernoulli's principle. And also even the roofs will be there. Roofs of the houses will be there, no? That will be always blown off whenever the wind is coming. That is also based on the Bernoulli's principle only. These and all are the applications of different applications of Bernoulli's principle. In that, first of all, we will discuss about the Venturi meter. Venturi meter. Draw the diagram. You draw, na? Small change is there. You have to draw just like this. Change it. So only you have to use the pens, erasers, and then pencils. Duster is pa. Namige andre duster ide. Eraser ಇದೆ ಬಟ್ ರಬ್ ಆಗ್ತಾ ಇಲ್ಲಲ್ಲ, ಯಾಕೆಂದರೆ ಪೆನ್ ತೊಟ್ಟು ಹಾಕಿದ್ರಲ್ಲ ಡಯಾಗ್ರಾಮ್. I think it will give the same answer only. Just keep like that only. We'll try. Strike ಮಾಡಿದ್ರ ಆಲ್ರೆಡಿ. I think so. It will give the answer same only. We'll try once. Based on your luck. ఈ తొక్కలో నోట్స్కి మళ్ళీ లక్ ఒకటి మళ్ళీ. It's done. Again you people are changing, huh? I think it will give the answer, same answer only. We'll try. Drop ಮಾಡಿದ್ವಿ already. ತಡಿ ಮಾಡ್ತೀನಿ. Then you can change the fluid direction, right? From this direction. You strike everything, huh? We can change the direction of fluid, no? From that side to this side for the previous diagram. ಪರಮಾನಂದ ಶಿಷ್ಯರು ಎಲ್ಲರೂ ನಮ್ಮ ಶಿಷ್ಯರೇ, ಪರಮಾನಂದ ಶಿಷ್ಯರೆಲ್ಲ. Done. Finished? Now you change the diagram again. Draw the previous one. See that fluid is flowing from this side to that side. In the previous diagram, what you can do, nothing but you can draw the arrow in this direction. Then you can get the same answer only. See, here in this pipe what happening means the fluid is flowing. You have to find out the velocity of the fluid at point A and then point B I have taken. So you have to find the velocity at point A means you have to relate the point A and B, and then you have to apply the Bernoulli's theorem at A and B. So for that purpose, first of all, what is the purpose I said? For what purpose we will use the venturi meter? You have to find out the speed of the fluid at any given point, any given cross section. So you have to find out at point A for now, as per now. Now let me take, this is point A and then this is point B. Both the points are at the same level only. So as per the Bernoulli's theorem, the pressure energy per volume, kinetic energy per volume and then potential energy per volume is equals to constant. If you write the equation and in the initial and then final cases, let me take at A and B, you are applying the Bernoulli's theorem. At A, what is the pressure energy per volume? What is the pressure energy per volume? Pressure at A is PA, you can take it as PA, otherwise P1, anything you can take. P1 plus kinetic energy is how much? Half rho into V1 square. So that half rho V1 square plus potential energy per volume is how much? Mg into how much height is there? H is there. So that rho G into H. That is at point A. At point B, the pressure is how much? Pb, let us consider, otherwise P2. Plus the velocity is how much here? V2. So that half rho into V2 square plus potential energy per volume is how much again? Rho G into H. Now here what will get cancelled? Obviously rho GH gets cancelled. Here we will get the zero potential energy level per volume. What is the reason? Nothing but here both are at the same height only. When you take for the Bernoulli's theorem, we have taken the pipe like this with the different heights. But now these 2 points A and B are there at the same height only. You have to take exactly points only. So same height, nothing but they will have the same potential energy. So the change in the potential energy will be how much? 0. Now what is the pressure at A? Tell me. What is the pressure at A? How much? P1 is equals to how much? See this is open to the atmosphere, right? Yes, very good. P0 plus, let us consider rho H is not there. Why? Because H is there here only. Let us consider this height as x. Anything you can take. And then even this height is x means this height also how much? X only. So this is x and then that is x I consider. Now at A, pressure is P1. P1 is equals to what I can write? P0 plus rho G into what is the height of the liquid column? X is the height of the liquid column. Then P2 is equals to P0 plus, again it is open right for the atmosphere, P0 plus, then what will you get here? Rho G H plus X. Why? Because total height is here H plus X. Rho G H plus rho G X. Now I want to find out the pressure difference. Before that we will see here P1 minus P2 is equals to what I can write, half rho into V2 square minus V1 square. I want to find out the V1 value only, we will solve that. Before that, P1 minus P2, what is P1 minus P2 here? Whenever you do P1 minus P2, what will be remaining for us? Only rho GH will be remaining and minus will be there. That minus, why we got this minus here in the Bernoulli's theorem? The fluid is flowing outside. The pipe is losing the fluid, right? At that time we got the negative work done. So that only what is the formula we got? Minus P1 A1 into velocity V2 into delta T we got. That is what we got in the work done. Why? Because the pipe is losing the fluid. Otherwise pipe is doing the work there. So here also we will get minus rho GH. That is just indicates that from here the fluid is ejecting out at second cross section. So that will be how much here? That is just rho GH is equals to what I can write, half rho into V2 square minus V1 square. Now I want to get only V1. I want to remove the V2. How to remove that? Yes, very good. You have to apply the equation of continuity. Can we apply the equation of continuity at A and B? A and B, we can apply the equation of continuity. What is the equation of continuity? A1 V1 is equals to A2 V2. From that, V2 is equals to what I can write? A1 by A2 into V1. Correct? A1 by A2 into V1. So that half rho into A1 square V1 square by A2 square minus V1 square. Why? Because V2 square is there here for us. Now this is rho GH here. Rho gets cancelled. Then I can take V1 square common. Then what will be remaining here? A1 square by A2 square minus 1. Correct? If I take V1 square common, then 2 will come here. That is how much? 2GH. Then V1 square is equals to 2GH divided by A1 square divided by A2 square minus 1. Correct? As it is we have written? Yes, everything is correct. Then V1 is equals to under root 2GH by under root A1 square by A2 square minus 1. Clear? That is the velocity of the fluid at the point A. If you want to find out at point B, then what you have to do? You substitute this value in this equation, then you will get the V2, that's it. So before listen here again. So before finding everything, first of all, for all the applications from here onwards until the surface tension, everything will be based on the Bernoulli's theorem only. So any different areas, different velocities are there means immediately you have to apply the Bernoulli's theorem. Before that, in this pipe the fluid is flowing with different velocities. Here the velocity is different, here the velocity is different. And which velocity is more among the V1 and V2? Which is more? V1 is more. Why? Because less area, more velocity. More area and then less velocity here. Now you have to find out the V1 value. For that purpose only we will use the venturi meter. So here like this 2 open pipes will be there for that, which will be open to the atmosphere. Now I have to find out the V1 means, first of all I will select the point A and then point B exactly at the open pipes, at the just below the open pipes, which are having the areas A1 and then A2. The velocity of the fluid is how much? V1 and then V2 at that points. Now you have to apply the Bernoulli's theorem exactly at point A and then point B. At point A, the pressure is how much? Nothing but I will consider that as P1, just as per now P1. And then kinetic energy per volume is how much? Half rho into V1 square. Potential energy is how much here? Potential change in the potential energy per volume is how much? Rho G into H only, right? Rho G into H nothing but height is how much height is there? Same height both are having. So that only rho GH have written. For the second case again, initial is equals to final. For the final case, again what you have to do? Nothing but again you have to apply the Bernoulli's theorem. That is, the pressure is how much? PB here, otherwise P2. Then kinetic energy per volume is how much? Half rho into V2 square. And potential energy is how much? Again rho G into H only. See, both are having the same height, so only there is no work done by the potential energy. Work done by the potential energy is how much? 0. Why? Because change in potential energy, mg rho G into H2 minus H1. H2 minus H1 is equals to how much here? 0. So only that is getting cancelled. Now you have to take the pressure difference one side, again you have to take the kinetic energy another side. So pressure difference P1 and then P2 I am taking here. For P1, P2 you have to take separately. From the Pascal law you can find out that. So at this point, for example, this fluid level is same. At that time what I can say? If the fluid level is same above that, then what I can say? Pressure is same at point A and B. Just pressure at 2 points will be same whenever they are having the same liquid column. Here liquid column is different. How much difference is there here? H difference is there. So only the the gauge pressure, how much we got, nothing but that is H rho g only directly. Instead of solving this much and all, directly you can apply that from here to here everything is same. So pressure is same from here to here everything. Then extra pressure is how much is there here, nothing but that is a gauge pressure will get absolute pressure, otherwise we call it as, that is how much is there, H rho g is there. That is what you will get at point 1. We will have, let me take this x, nothing but this is also how much, x only. So open to the atmosphere. So pressure P1 is equals to P naught plus rho gx, and then second one at point B, again P naught plus rho g into how much height is there here, h plus x is there. So that only rho g h plus rho g x we have taken. Again if you are finding the pressure difference, at that time what will getting, rho g into h will get, rho g h is equals to half rho v2 square minus v1 square. Till here we got, and after that we have to apply the equation of continuity. To remove the, I have to find out the v1, nothing but you have to substitute the v2 value. If I want to find out the v2 value means what I have to substitute, v1 value I have to substitute. How to get that velocity is nothing but you have to apply the equation of continuity. Equation of continuity, Gautam. Hello, idara class alli hogidra, nidi swapna lokaniki hoinava poyali mongar kochukopo. So here equation of continuity you have to apply. A1 v1 is equals to, amma Akshita, good morning, hello, hello everybody, idara ellaru Congress party namdu, hello, hi. So A1 v1 is equals to A2 v2. From that v2 is equals to how much we got, A1 by A2 into v1. That is what you have to substitute here in this one. Then what we can get, nothing but we can get the v1 value directly. Clear? Nim kante Barmasagara Barmasagara students better. Barmasagara na now Saturday hogta idwala. ಯಾವುದು ಯಾವುದು A1 by A2 ಅಂದರೆ ಎಲ್ಲಿ A1 by A2 ಬರ್ತಾ ಇದೆಯಲ್ಲ, ಮತ್ತೆಲ್ಲ ಕರೆಕ್ಟೇನಾ, ಇದೆಲ್ಲ ಡೆರಿವೇಷನ್ ಅಲ್ಲ? ಎಲ್ಲಿ ಇಲ್ಲಿ ಮೈನಸ್ ತಗೋಬೇಕಾ? ಮೈನಸ್ ತಗೊಂಡಿವಂದರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇದು ಮೈನಸ್ 2gh ಆಗುತ್ತಲ್ಲ, ಇದು 1 ಮೈನಸ್ ಆಗುತ್ತಲ್ಲ, ಅವಾಗ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆನಾ? ಎಸ್, ಲುಕ್ ಅಟ್ ದಿಸ್, ಕರೆಕ್ಟ್ ಓನ್ಲಿ, ವೆರಿ ಗುಡ್. See here, A1 and then A2, A1 is smaller right here, in this case A1 is smaller and then A2 is larger. So whenever you see smaller by the larger value, nothing but you will get the value in terms of what, minus you will get it. So instead of that, we already got minus rho gh right here. P1 minus P2, nothing but how much we got? P naught rho gh gets cancelled. How much is there? Minus rho gh is there. So minus rho gh if you substitute here, then what will you get here? This will be 1 minus A1 by A1 square by A2 square. Correct? I am just multiplying with minus both the sides. That's it. I am not doing anything. Then what will you get here? This will be 1 minus A1 square by A2 square. Correct. For the previous diagram it will be correct, I think. Last diagram whatever I drawn. ನಿದ್ದೆ ಮಾಡಬೇಡ್ರಮ್ಮ ಸ್ವಲ್ಪ, ನಿಮಗೆ ನೋಡಿದೆ ಅಂದರೆ ನಮಗೆ ನಿದ್ದೆ ಬರ್ತಾ ಇದೆ. ನಾವು ಮಕ್ಕ ಎಲ್ಲರೂ ಮಕ್ಕಬೋದಲ್ಲ. ಕೀರ್ತಿ, ನಿಮ್ಮ ಕ್ಲಾಸ್ ಅವರು ಯಾರು ಅಡ್ರೆಸ್ ಇಲ್ಲ, ನಿಮ್ಮ ಕ್ಲಾಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಯಾರು ಅಡ್ರೆಸ್ ಇಲ್ಲ, ಗರ್ಲ್ಸ್ ಅನುಷ ಎಲ್ಲ ಹೋಗಿದಾರಾ? ಟಿಜಿ ವಾಟರ್ ಬಾಟಲ್ ಎಲ್ಲ ಇದೆ ಬೇಕಾ ಗೌತಮ್? ಸ್ಪೀಡ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಸ್ ಎಷ್ಟು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾ ನೀವು? That students will sit for 3.5 hours continuously. In this afternoon time, I have the first year class actually. And second year class, I have taken 10 minutes less, so that they have told to their principal also. She is taken 10 minutes less, so we want some more class still like that. Up to 8 o'clock we are taking the class. See, ನಿಮ್ಮ ಮುಖ ನೋಡಿದ್ರೆ ಅಂದರೆ ನಮಗೆ ಕ್ಲಾಸ್ ಮಾಡೋಕ್ಕೆ ಇಂಟ್ರೆಸ್ಟ್ ಬರ್ತಾಯಿಲ್ಲ. ಏನು 1 ವೀಕ್ ಒಂದ್ಸಲ ಮಾಡಿದೆ ಅಂದರೆ ನಮ್ಗೆ ಕೂಡ ಹಂಗೆ ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರ. ವರುಣ್ ಎಲ್ಲಿ ಹೋಗಿದ್ರೆ? ಯಾಕೆ? ಅವ್ರಿಗೆ ಹುಷಾರಿಲ್ಲ ಅಂದರೆ ದಾವಣಗೆರೆಗೆ ಹುಷಾರಿಲ್ಲಲ್ಲ. ಸ್ಯಾನಿಟೈಸೇಷನಾ? ವ್ಯಾಲೆಂಟೈನ್ಸ್ ಡೇಗೆ ಇವಾಗಿಂದನೇನಾ? ವ್ಯಾಲೆಂಟೈನ್ಸ್ ಡೇ ಯಾರಿಗೆ ನೆನಪಿಲ್ಲ? TGR ಜಾಗ ಒಬ್ರಿಗೆ ನೆನಪಿದೆ. ಎಷ್ಟು 7 ಡೇಸ 9 ಡೇಸ ಮಾಡ್ತಾರಲ್ಲ? ಎಷ್ಟು ದಿವಸ ಮಾಡ್ತಾರೆ? 14 ಡೇಸಾ? 14 ಡೇಸಾ? ಏನೋ ರೋಸ್ ಡೇ, ಚಾಕ್ಲೇಟ್ ಡೇ ಏನೇನೋ ಮಾಡ್ತಾರಲ್ಲ. ನಿಮಗೆ ಅಂದರೆ 3-4 ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ಇದ್ದಾವೆ. ನಮಗೇನೈತಿ? ನಮಗೆ ಗೊತ್ತಿಲ್ಲ, ಅದಕ್ಕಾಗಿ ನಾನು ಕೇಳ್ತಾ ಇದ್ದೀನಿ. ಇಲ್ಲಾಂದ್ರೆ ಯಾರು ಕೇಳ್ತಾರೆ ನಿಮಗೆ? ಡನ್ನಾ? ಉದಯ್ ಒಂದೊಂದು ಇಯರ್ಗೆ ಒಂದೊಂದು. Right, Venturi meter is finished. Next, Torricelli's theorem. Torricelli's theorem. ಸಾಕು ವ್ಯಾಲೆಂಟೈನ್ ಡೇ ಅಂದಿನ ನಾನು ಫುಲ್ಲು ಮಾತಾಡ್ಕೊತ ಇದ್ರು. ಹಾಂ, ಏನೋ ಗುಸು ಅನಿ. ಏನು ಹರ್ಷ? ಉದಯ್ ಸಿಕ್ಕಿದ್ರ ಸಿಕ್ಕಿಲ್ಲ? ಏನು ಏನಂತ ಅರ್ಥ ಆಗಿಲ್ಲ. ನಮ್ಮ ಆಶೀರ್ವಾದ ಕೊಡಬೇಕಾ? ನಮ್ಮ ಆಶೀರ್ವಾದ ಯಾವಾಗಲೂ ಇರುತ್ತೆ ನಿಮಗೆ ಆ ವಿಷಯದಲ್ಲಿ ಮೇಯ್ನ್ಲಿ. ಎಷ್ಟು ಬೇಕು? 1-2? ಎಷ್ಟು ಬೇಕು? 1-2? ಅಷ್ಟು ಆಶೀರ್ವಾದ ಕೊಡ್ತೀನಿ. ಹಾಂ, 1 ಸಾಕಾ? ಏನು ಯುವರಾಜ, ಒಂದೊಂದು ಅವ್ರು ತೊಗೊಂಡು ನಿಮ್ಗೆ ಒಂದು ಕೊಡಬೇಕಾ? ಏನು ರೈಟ್. Torricelli's theorem or velocity of a flux. This is again based on the projectile motion only. Everything will be related to that. Here in a container which is having a bigger area, here open area, and then here smaller orifice is there. Orifice, otherwise hole. This is known as orifice of area, very small area, that is, let me take small a. And now at this point if you see, whenever the water is coming out of this point, then what happens at A? What happens at A? Level will decreases, right? The water will be falling down here. Water level will be falling down, and then here the water will be coming out of this orifice. So at that time mainly you have to understand the mechanism here. Whenever the water is coming out of this here, then what happening here? Water level is decreasing. So that water level velocity is, let me take the V1. Can I say that V1 is equals to 0? V1 is equals to 0. Why? Because it is falling freely, right? this water level is just falling under the gravity only. It is falling freely. So the initial velocity becomes how much? 0. And now, and also one more thing you have to remember is here, this is open to the atmosphere, so pressure is how much here? P naught. Now, whenever I say inside here, what is the pressure? Tell me. At this point, what is the pressure? P naught plus rho GH. Whenever I say here exactly at this hole, what is the pressure? Hole. Hole is open to the atmosphere. Hole is open to the atmosphere. Only which pressure will be there? Nothing but only atmospheric pressure will be there. If I say inside fluid weight is there on that, so that what will get? Nothing but P naught plus rho GH. Whenever I say at this hole exactly means at that hole is exactly open to the atmosphere. From here outside air is playing in that. So that air is applying some pressure on that. That will be how much? Nothing but P naught only. If I say little bit inside also, here also, then what is the pressure? P naught plus H rho G, right? But here exactly here how much pressure is there? Nothing but exactly how much? P naught. You understand, right, that concept mainly? So whenever the water is coming out of this orifice, at that time here fluid level is falling freely. Initial velocity is how much? 0. And also the pressure at this point is, at the top point is how much? Nothing but P naught only, atmospheric pressure. At this hole, if you see, this hole is open to the atmosphere. So atmospheric pressure is how much? P naught. If I say little bit inside also, exactly here also what will be there? Nothing but P naught plus rho GH will be there. Clear? Now exactly at the hole only I am measuring the pressure. Now you have to apply the Bernoulli's principle between the point A and B. Tell me that which energies are there? Potential energy A and B, exactly at A. Exactly at A, nothing but it is having the height H. Point B is having how much height? H minus H. So that potential energy also there. Velocities are there. Kinetic energy is there. And also pressure is there. So that pressure energy also there. Everything is there. Now you have to apply the Bernoulli's theorem between A and B. At A, what is the pressure exactly? P naught. P naught is the pressure energy. Plus kinetic energy is how much? Half rho into V1 square. How much it is? 0. Why? Because the water level is falling freely. Plus, what is there? Rho G into, what is the height of point A? H is the height of the point A. That is the P naught plus rho GH will get. P naught plus rho GH plus half rho V1 square. Then next one is at point B. Point B is also, pressure is how much? P naught. Kinetic energy is how much? Half rho into exactly how much? V square plus again potential energy is how much there? Rho G into H minus H. From ground only you have to measure always height. Height of point A from ground is how much? Capital H. Height of point B from ground is H minus H. Now in this P naught gets cancelled. Rho GH and then rho GH also gets cancelled. Then what is remaining here inside? 0. Then what is there outside? That is half rho V square minus rho GH. Clear everything? Then V square is equals to, what I can write here? 2GH and then V is equals to under root 2GH. Clear? Rho gets cancelled however. So that is about the velocity of a flux is equals to how much? Nothing but under root 2G into H only. But this height is which height? Most of the people will get confused here only. This is a height from where? From the top point, not from the ground. From the ground how much is there? H minus H is there. From the top of the container how much height? Nothing but depth. Actually we can assume that as a depth only. Depth of the hole from the top of the tank. So that is H is the depth here. V is equals to under root 2GH. Next you have to find out the time of flight as well as range also. First of all we will find out the time of flight. For finding the time of flight is equals to, which formula you have to use for the time of flight? Displacement equation. Sy is equals to uyt plus half ay t square. This is a horizontal projectile here. The time taken from hole to the ground you have to find out. That is the time of flight here. So you have to use the displacement equation as Sy is equals to uyt plus half ay t square. Now exactly everything you have to discuss about the water only here, water which is coming out, a flux only. Now how much displacement is there? Vertical displacement from the ground is how much? For this is a projectile here. How much height is there? Height of the tower is how much? H minus H only. This is like a horizontal projectile only. From the height of the tower we are projecting something horizontally. So height of the tower is how much here? H minus H. h minus h is equals to, the velocity is there only along which axis? X axis. So that uy becomes how much here? 0. Ux is equals to v, but uy becomes how much? 0. So that is 0 plus half into, this flux is moving under gravity only, right? Ay is nothing but what? G only. So that half g into time of flight square. Then t is equals to what I can write? Under root 2 into h minus h by g. Correct? Generally what is our formula? Under root 2h by g. From ground how much is height is there? Nothing but h minus h is there. That is the time of flight. Next, range formula. Range nothing but which displacement equation will use? Horizontal displacement. Why? Because this is a range here, horizontal displacement. So that what I can use nothing but Sx is equals to uxt plus half axt square. Sx is nothing but what? Range, or ux is how much? Horizontal velocity is how much here? V. Then v into t is nothing but time of flight. Half ax value becomes how much? 0. Only gravity is there only under y axis. Along the x axis nothing, no gravity. So that only ax becomes how much? 0. Then here r is equals to, velocity is how much we got? Under root 2g into h, just before we got. Time of flight is how much? 2 into h minus h divided by g. Then g gets cancelled here, root g. Then what is remaining here? R is equals to just 2. Root 2 will be 2, and then 2 into what is remaining? H into h minus h. And also you have to find out the hole should be where, so that we will get the maximum range. For getting the maximum range, what should happen? Nothing but exactly this hole should be there in middle, exactly. Middle nothing but what I can say? H is equals to h minus h. When the range will be maximum nothing but whenever the hole is there exactly at the half of the height of the tank. So for that what I can say? Nothing but for R max we can get that h is equals to h minus h. Middle nothing but what I can say? This distance is equals to this distance only. So that small h is equals to how much you will get here? 2h is equals to capital H. Then h is equals to how much? H by 2 exactly. Whenever you substitute that value in the R maximum, I want to get the R maximum means, what is the formula for us? Under root 2 into h minus h. So 2 into this h will be how much? H by 2, h minus h by 2. How much will you get? Root h by 2 nothing but h by 2 will get. Then 2 into h by 2 means how much will you get? Exactly h. So R maximum is equals to how much? Nothing but exactly height of the tank. Whenever the hole is there exactly at the middle of the tank, at that time what happens? Nothing but it will have the maximum range. That maximum range value exactly equals to how much? Height of the tank only. Okay. So listen again, Torricelli's theorem. What is the purpose of Torricelli's theorem? Nothing but here whenever the fluid is coming out of the hole, otherwise out of the tap, whenever we just connected one pipe exactly at the bottom of the tank, at that time water will come out. That is known as the velocity of efflux. That velocity you have to find nothing but you have to apply the Torricelli's theorem. Let us consider the open end of the tank is A and this hole is at point B. You have to apply the Bernoulli's theorem at point A and then B. So I have applied Bernoulli's theorem between A and B. Point A is there at height, how much height? H height from the ground. Point B is there at what height? H minus h height from the ground. So that you will get the potential energy. Both are having the velocity, so that you will get the kinetic energy. Both are open to the atmosphere. So how much pressure is there? P naught is the atmospheric pressure. You have to mainly understand this one. This hole is open to the atmosphere, so that whichever is open to the atmosphere, there what is the pressure? Nothing but atmospheric pressure P naught only. Now we have to take the pressure energy per volume, kinetic energy per volume, and then potential energy per volume at point A and then at point B. So pressure is how much? P naught. At B also P naught only. Kinetic energy is how much? Half rho into V1 square, half rho into V2 square. And then potential energy is how much here? Rho g into how much height h, and then here rho g into h minus h. Equate them by the Bernoulli's theorem. Then I can cancel everything. Then we are getting the velocity is how much? Under root 2gh. Here h indicate the depth of the hole, that you have to remember. Most of the people will confuse and then directly they will substitute this value here, height nothing but. You have to remember that is the h is the depth of the hole from the top of the tank. that is about the velocity. Then time of flight. You have to find out the time of flight of this fluid jet. For that, finding the time of flight, you have to use the displacement equation along the y-axis. Sy is equals to uyt plus half ayt square. This velocity of the jet is there only along which axis? X-axis. Along the y-axis, how much velocity becomes? 0. Then displacement of this projectile is at what height? Nothing but h minus h height from the ground. So h minus h half into, it is moving under the gravity, so that half gt square I got. Then time of flight value we got here. Then after that you have to find out the range. For finding the range, you have to use the equation of horizontal displacement. Why? Because what is the range? Nothing but maximum horizontal displacement travelled by the projectile. So here horizontal displacement nothing but Sx is equals to uxt plus half axt square. Sx horizontal range only, and then velocity along the x-axis, how much we are having here? V is the velocity, so that V into, it is covering entire projectile. So that what is the time covering the entire projectile? Nothing but time of flight only, plus half ax into t square. This water jet is purely moving under the gravity. Gravitational force is there only along which axis? Y-axis. Along the x-axis, no gravity, no acceleration. Then time of flight value you have to substitute here. By that, we got the range as how much? 2 into under root h into h minus h. When the range can be maximum means, in the projectile, when the range can be maximum? When the range will be maximum, whenever theta is equals to exactly 45 degrees. R maximum will be there at theta equals to 45, and the relation between h and r is how much we got? H is equals to r by 4 tan theta. That is the relation. Tan theta is 1, then h is equals to r by 4 we will get. That is in the oblique projectile. In the horizontal projectile, the range will be maximum whenever h is equals to r. In the tower problems also, the same thing here also. Here height of the tower should be is equals to the range. How to get that? Nothing but whenever the hole is there exactly at the middle of the tank. Exactly at middle of the tank, nothing but from the top to bottom same heights only will be there. So the h is equals to what I can write? H minus h. So from that h is equals to h by 2 I can write. I have substituted that value in this equation. Then maximum range is equals to exactly how much? Height of the tank only. Clear? Copy that. Speed of a flux. incompressible liquid flows as shown in the figure. An incompressible liquid flows as shown in the figure. An incompressible liquid flows as shown in the figure. Calculate the speed v of the fluid of the fluid. How to find out the v? What? Law of continuity. Yes, sir. Equation of continuity. Very good. You have to apply the equation of continuity here. The fluid entering is equals to the fluid leaving. You have to take like the Kirchhoff laws. Apply and then get the answer. Hello. Hello. Sir. Hello, sir. ಹೌದಾ, ಒಂದು ನಿಮಿಷ ಇದೆ, ನಾನು ನೋಡ್ತೇನೆ, ಡೇಟ್ ನೋಡ್ತೇನೆ ಸ್ಟೂಡೆಂಟ್ಸ್. ಹೌ ಮಚ್ ನಾನಾ ಟೂನಾ ನೋ ಅರೆ ಡೇಟ್ ಯಾರು ಹಾಕ್ತಾರೆ ನೋಟ್ಸಲ್ಲಿ? ಫ್ಲೂಯಿಡ್ಸ್ ಯಾವಾಗ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೀನಿ ನಾನು ನೋಡಿ? 24th. ಹಲೋ 24th ಅಂತ ಸರ್. ಫ್ರೈಡೇನಾ? ಫ್ರೈಡೇನಾ? ಯಾವ ಫ್ರೈಡೇ? ಹೌದಾ, ನೋಡಿರಿ ಅವಾಗೇ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದೆ ನಾನು. ಅದು ನೋಡಿರಿ, ನಾನು ಕ್ಲಾಸಲ್ಲಿದ್ದೀನಿ, ಮತ್ತೆ ಕಾಲ್ ಮಾಡ್ತೀನಿ. 1 is the correct answer. 2ನಾ? 1 is the correct answer. ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದಾದ್ಮೇಲೆ ರೈಟ್ ಸೈಡ್ 0 ಇಟ್ಟಿದ್ರಮ್ಮ. ಮೇಧಾವೀಸ್ ಪರಮಾನಂದ ಶಿಶುರಾಲು. Here what will you get? Nothing but you have to apply the equation of, whenever you see the areas and then velocities, blindly you apply the equation of continuity. That's it. This is same like the Kirchhoff current law only. The fluid entering the pipe is equals to the fluid leaving the pipe. That's it. The amount of fluid entering the pipe. See here, from here to here, how much ever water came, that water only will come outside here. Is there anything extra coming in between? Nothing, right? So the amount of fluid entering inside is equals to the amount of fluid leaving. Entering is equals to leaving, nothing but what? Continuity. What is that? Continuity equation only. Equation of continuity. So what I can write? Nothing but A1 V1 is equals to whichever the fluid coming from inside from here, it is coming out from here. So that what I can say? A2 V2 plus A3 V3. You got the same way? Yes. The fluid entering in is equals to the fluid flowing out. So that A1 V1 is equals to A2 V2 plus A3 V3. A1 is how much here? 0.12, and then into V1 is how much? 3 is equals to A2 is how much? Again 0.12 only. The velocity is, I will take as 3 by 2, 1.5. Then plus A3 is how much here? 0.18 into velocity V I have to find out. Then I will cancel the 0 point here every side. Point I will cancel. Then I can cancel even with 6 also. 6 2s are 6 2s are and then 6 3s are. This 2 2 also gets cancelled. That's it, huh? This is 6, right? Then again 3 3 also gets cancelled here. What is remaining here? 2 is equals to 1 plus V is remaining. That's it. Nothing is there. Then V is equals to what I can say? 1 meter per second. How you got 2 meter per second? You left here, you left 0, na? Everything cancelled, so that with 0 you have taken, huh? A1 V1 is equals to simply A2 V2. That's it. Where this fellow will go? That fellow is there now already. Understand, right? That kind of problems will come. Next one. The cylindrical tube of a spray pump has a cross section of 8 centimeter square, one end of which has 40 fine holes, fine holes, ಚೆನ್ನಾಗಿದ್ದಾವೆ ಹೋಲ್ಸ್ ಅನ್ನೇ ಅರ್ಥ. 40 ಅರ್ಥ ಆಯ್ತಾ? ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕಾ? 40 ರಂಧ್ರಮ್ ಇದ್ದಾವೆ. ರಂಧ್ರಮೇ ಅಂತಾರೆ, ಏನಂತಾರಮ್ಮ? ರಂಧ್ರಮೇನಾ ಕನ್ನಡದಲ್ಲಿ ಏನಂತಾರೆ? ಕೀರ್ತನ, ರಂಧ್ರಮ್ ಕರೆಕ್ಟೇನಾ? ಐ ನೋ ದಿಸ್ ಮಚ್ ಆಫ್ ಕನ್ನಡ. ಈ ಪಕ್ಕ 40 ರಂಧ್ರಮ್ ಇದ್ದಾವೆ, ಇಲ್ಲಿ ಸ್ಪ್ರೇ ಪಂಪ್ ಇದೆ. fine holes of area 10 power minus 8 meter square, 10 power minus 8 meter square. If the liquid flows inside the tube, inside the tube with a speed of 0.15 meters per minute, then find the speed with which liquid is ejecting out. How much? 2 na? No, wrong. No, wrong. Check properly. How much? 40 na? 40 ಇಂಟು ಏನೇನೋ ತಗೋಬೇಕು. 5 ಬರುತ್ತೆ ನೋಡು, ಚೆನ್ನಾಗಿ ನೋಡು. Again, what you have to apply? See, two areas given, one velocity given, nothing but immediately what you have to apply? Equation of continuity. That's it. Yes, very good, Yuvraj. Very good. See the units properly. 5 is answer. Yes, very good. Five meter per second is the correct answer. Exactly. Have you converted the units? How much I have given? 0.15 meters per minute I have given. Check that. You have to convert into seconds. Check at this. Check out the problem. Let me take, this is the area A1 and then this is the area A2. This second area is having how many holes? 40 holes. Each of how much area? 10 power minus 8 meters square. 10 power minus 8 meters square. So total area will be how much? 40 into 10 power minus 8. One hole is having 10 power minus 8 means 40 holes will have 40 into 10 power minus 8 only. That is what the area in the second section you have to find out. That is the main thing in this problem. Now I have to apply the equation of continuity, that is A1 V1 is equals to A2 V2. A1 is how much here? 8 centimeter square, nothing but 8 into how much? 10 power minus 4. V1 is how much here? See that velocity 0.15 meters divided by minute. You have to convert into what? Meter per seconds you have to convert. So that 0.15 meters is as it is. Minute means how much I can take? 60 seconds. Now our units meter per seconds came. So meter per seconds. Then remaining value is how much? 0.15 by 60. That is the velocity. 0.15 by 60 is equals to area 2 is how much? 40 holes are there. So that 40 into each is having 10 power minus 8 area and then into velocity V2 I have to find out. This is the velocity you have to find out, V. Now here cancel everything, that's it, you will get the answer here. Then if I cancel this one, then how much you will get here? 100 you will get. Then this will be 8 5s, yes, very good. Then 5 3s, this will be, and then 3 20s, 10 power minus 4. This is how much? Minus 4 will be remaining. This 10 power minus 3 will go up, right? This gone, nothing but 10 power minus 1 is there. That 10 power minus 1 is coming this side, nothing but 10 will be there. 10 by 2 is remaining, that is equals to V. Then V is equals to how much? 5 meter per second. See the calculation again. See, I have taken 8 5s directly I cancelled. Then here instead of 0.15 what I have taken, nothing but 15 by 100 I have taken. So here again 8 5s and then 5 3s, 3 20s finished, everything finished. In the denominator how many zeros are there? 1 2 3 are there. So 3 is going up. 3 and then minus 4. Minus 3 minus 4 will be minus 7, cancelling with minus 8. How much is remaining? Only minus 1 is remaining. 10 power minus 1 is coming this side, nothing but how much will be there? 10. That divided by, total divided by how much is there? 2 is there, so that we got it as 5 meter per second. That is how you have to do the calculations. Fast calculation should be done. Finish that is answer, 5 meter per second. How many of you got correct answer? Very less people. Good, good, very good. ಏನು ನಿಮಗೇನು 3 ಯಾಕೆ ಬಂತು ಆನ್ಸರು? ಹಾಂ, ಪರ್ ಮಿನಿಟ್ ನೋಡ್ಬೇಕು ಸರ್, ಅದಕ್ಕೆ ನಿದ್ದೆ ಮಾಡಬಾರ್ದು. ಯಾವುದು? ಏನೇನು ಸೆಕೆಂಡಿಗೆ? ಬಾ 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 ಬಾ, ವಾವ್, ಕ್ಲಾಪ್ಸ್ ಕ್ಲಾಪ್ಸ್ ಹೊಡೀರಿ ಒಂದು ಸಲ. ಎಸ್, ವೆರಿ ಗುಡ್ ವೆರಿ ಗುಡ್. ರಿಮೈನಿಂಗ್ ಪೀಪಲ್ ಕ್ಲಾಪ್ಸ್ ಹಾಕಿ ಕೂಡ ಅದು ಕೂಡ ನಮಗೆ ಲೇಜಿನೆಸ್ ಅಲ್ಲ. ತಿಂದಿಲ್ಲ ಇವತ್ತು ಸಾಂಬಾರು, ಬ್ಲ್ಯಾಕ್ ಪೆಪ್ಪರ್ ಸಾಂಬಾರು ಚೆನ್ನಾಗಿತ್ತಲ್ಲ, ನಾನೇ ಮಾಡಿದ್ದೀನಿ. ವಾಟರ್ ಈಸ್ ಫ್ಲೋಯಿಂಗ್. ಇವತ್ತು ನೀವು ತಿಂದಿರಲ್ಲ, ಅದು ಪಪ್ಪು, ಪ್ಯೂರ್ ಆಂಧ್ರ ಫುಡ್. ಅದರಲ್ಲಿ ಮ್ಯಾಂಗೋ ಪಿಕಲ್, ಗೀ ಇದೆ ಅಂದರೆ, ನೆಕ್ಸ್ಟ್ ಟು ದ್ಯಾಟ್ ಚಿಕನ್ ಈಸ್ ದೇರ್ ಆಲ್ಸೋ. ವಿಲ್ ನಾಟ್ ಟಚ್ ದಟ್ ಚಿಕನ್, ವಿಲ್ ಈಟ್ ದಿಸ್ ಓನ್ಲಿ. ದಟ್ ಮಚ್ ಆಫ್ ಟೇಸ್ಟ್ ವಿಲ್ ಬಿ ದೇರ್. ರೆಡ್ ದಾಲ್ ತಿಂದಿರಲ್ಲ ಇವತ್ತು? ಹಾಂ, ಪಲ್ಯನಾ? ಅದು ಕೂಡ ಪಲ್ಯನೇನಾ? Water is flowing through two horizontal pipes. Water is flowing through two horizontal pipes of different diameters which are connected together, water is flowing through two horizontal pipes of different diameters which are connected together. And in the first pipe, the speed of water is 4 meters per second. 4 meters per second, and the pressure is 2 into 10 power 4 Newton per meter square. 2 into 10 power 4 Newton per meter square. Then calculate the speed and pressure. Calculate the speed and pressure of the water in the second pipe. Calculate the speed and pressure of the water in the second pipe. The diameters of the pipes are 3 centimeters and 6 centimeters. 3 centimeters and 6 centimeters. Find out the answer. Read the question first. Then stop it.